Here we have problem number 1 from chapter 16. So we have the charge at rate is given. What is the induced magnetic field at a distance of 10 centimeters from the capacitor? Okay, so let's write it down, the given values. So this is first problem. So Q over T is given as 0.03 coulomb per second. And distance is given, which is 10 centimeter. You have to find B induced. The formula of it, as we know, that mu naught current divided by 2 pi r. Okay, D or R, and your I is equal Q over T. So mu naught Q 2 pi r Q over T. So if you plug it, you should get the answer. Next problem. So in the next problem we have a frequency. What is the wavelength in the vacuum? Okay, the second problem we have frequency is given, which is 450 megahertz. You have to find wavelengths in a vacuum. So as you know, the speed in a vacuum, speed of the light, is 3 times 10 to the power of 8 meters per second. So lambda times frequency is c. Okay, from there lambda is equal c over frequency. So if you divide it, you should get the answer. Okay, third problem. What is given? In the third problem we have frequency. Maximum magnetic field is given. What is the maximum electric field? Okay. So in the third problem we have a frequency which is 760 kilohertz. Maximum magnetic field is initial one, or B0, B naught, which is 4.75 times 10 to the power of minus 11 Tesla. You have to find maximum electric field. So we know the formula where maximum electric field is equal speed of light multiplied to the maximum magnetic field. So if you plug the numbers, you should get the answer. Okay, problem number 4. We have 100 watt light bulb produces the same intensity of the light as 75 watt light bulb produced 10 meters away. You have to find a distance, correct? Okay, so in problem number 4 we have power 1, which is 100 watt. Then we have power 2, 75 watts, and then we have distance 2, which is given 10 meters, or this is also radius 2. You have to find D1 or radius 1. So the formula is basically intensity is equal power divided by the area. So since it's electromagnetic wave, so it has spherical area of the surface, so spherical, which is equal to the pi. The area will be 4 pi r squared. This is a general formula. Okay, in particular this case, if the intensities are the same, that means P1 divided 4 pi R1 squared is equal P2 divided 4 pi R2 squared. So from there you have to find what is the R1. So the R1 will be, this 4 pi cancels out. So P1 divided by P2 multiplied R2 squared under the square root.